Good evening to all of you. I hope my voice is clear to all of you, my dear. Good evening to all of you. Good evening to all of you. So today is the lecture number 10. So in yesterday class we have discussed two topic of GVF. One is the dynamic equation. We have derived the dynamic equation of GVF, dynamic or differential equation, whatever you say. And second part, there is a length of GVF profile, how to calculate that, how to derive the formula for that we have discussed in previous class, that means yesterday class. So today is the gradually varied flow part 2. Today we are going to discuss about classification of slopes. We are going to solve some problem also related to that. Okay, so let's start. So today's these three topics we have discussed. Now fourth topic of your GVF, that is classification of GVF. This we are going to discuss. Let me check this PDF. I think 1 second here. I think I have added the wrong PDF. Now it's clear. So today we need to discuss about is nothing but the classification of slopes. Classification of slopes. This we need to discuss it today. So in this, first of all, up to what point we have discussed yesterday? Why this PDF is not there? One second here. I think there is some technical error. Let me correct that. Okay. So today, as we are telling, we are going to discuss about classification of slope. Classification of slopes. So now the first thing which we need to understand, that after getting the dynamic equation, getting the dynamic equation for GVF, we have also two equation which is given by Mannings and Chages for same dy upon dx only, and these two equations we are calling as modified GVF equation. Modified GVF equation. So this is dy upon dx s naught 1 minus yn upon y to the power 10 by 3 divided by 1 minus yc upon y to the power 3. So this formula we are getting. And in changes similar to this only, but there is small change here. It is yn upon y to the power 3. And it is yn minus yc upon y to the power 3. So only minor changes there between both this formula. And this formula is nothing but we call as modified differential equation of GVF. It is very, very important formula for us. Now in this two depth I have used, one is the, not two, you can say three depth I have used. One is yn, that is a normal depth. Second is the yc, that is a critical depth. And y is the, at whatever section, at whatever location you are finding now, at that point, whatever the depth is that is something we are calling as y. Now if you look at my dear here, I have given you how to calculate normal depth as critical depth. For critical depth, already I have given you the complete detail how to calculate critical depth for any cross section. So depth of flow where energy is minimum for a particular discharge, that flow we are calling it as critical depth. And normal depth is depth of flow that could occur if the flow was uniform and steady and usually predicted using the Manning's equation. So normal depth normal depth you have to always find out with the help of Manning's equation only, and normal depth generally occur when the flow is uniform and steady. So in that case, the normal depth will be occurring to you. Now, what is normal depth? What is critical depth? I think you guys have understood. Now, what I'm going to do, I'm going to divide this complete water surface slope into 5 parts. First one is the mild slope. Second one is the steep slope. Third one is the critical slope. Fourth one is nothing but the horizontal slope. And the fifth one is nothing but the mild, steep, critical, horizontal, and the last one is nothing but the adverse slope. Last one is nothing but the adverse slope. Last thing is nothing but the adverse slope. Okay. Now these slopes we have determined, like to classify these slope, we have used critical slope as a reference. Now if your slope is less than the critical slope, we call it nothing but the mild slope. Here the normal depth will be more than the critical depth. For steep slope, your slope will be more than the critical slope. Here the normal depth will be lesser than the critical depth. At critical slope itself, S0 will be equal to SC only, and your Yn is equal to Yc, critical point. In a horizontal slope, your S0 will be equal to 0 because it's a horizontal slope, so definitely the S value will be 0. And here Yn will be tends to infinity. In adverse slope, you can see this S0 will be negative. Name itself is telling you adverse slope. Here Yn will be also tends to infinity. So that's how we have classified all type of slopes. That's how we have classified all types of slopes. I hope you guys have copied. Now start with the first. I will be giving you a idea how to draw all the water surface profile in a different slope. So first of all, what you need to do for a mild slope, if I am drawing, let us draw 3 lines. Channel bottom, then this is the critical line, then this is the normal depth line. Let us name it. This is the NDL, not with this color. This is NDL, sorry. This is CDL, critical depth line. This is normal depth line. So 3 water surface profile is going to occur, M1, M2, M3. Already I have given you the condition for that, but what I want you to, how these water surface profile are formed, that you need to learn it. And for that, few things which I have already given you, just I am explaining to you. Like this equation you guys are knowing now, dy upon dx is equal to S0 1 minus yn upon y to the power 3 divided by 1 minus y t divided by y to the power 3. Now few things which I'm asking, all of you can answer me. Like in M1, that means somewhere here I'm asking. Here the depth condition will be what? Normal depth is more than the critical depth, and here if you are somewhere here, your actual depth will be also more than the normal depth. So y greater than yn, yn greater than yc. For this condition, if you see y greater than yn greater than yc, this condition if I am focusing about, what will be the dy upon dx value? Is it positive or negative? See, yn is less compared to y. So this value you are going to get less value. So 1 minus something lesser than 1 will give you positive value. Yc is greater. Yc is lesser, y is bigger. So again, this value you are getting lesser than 1. So if you take cube of that, again it will be less than 1 only. 1 minus something which is less than 1, again it will give you positive value. So positive divided by positive, it will be positive value. What does it mean? It means, it implies water surface, or it implies rising water surface profile. Rising water surface profile. Rising water surface profile. It implies rising water surface profile. It implies rising water surface profile. It implies rising water surface profile. Okay. Now look at the second case. In M2, what is the condition? Yn is greater than y and y is greater than yc. For this, if you calculate dy upon dx, what you will get it here? See, yn is greater compared to y. So this value you are going to get something more than 1. So 1 minus something more than 1, in the numerator part you are getting the negative value. And this yc is something lesser than y. So here lower part you are going to get positive. So ultimately dy upon dx you are going to get negative value. So at that case, what will happen? It implies falling water surface profile. 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 Is it clear? Is it clear? Now the next one is in M3. Condition is yn greater than yc and yc is greater than y. For this, if you calculate dy upon dx, upper part also you are getting negative, lower part also you are getting negative. So ultimately you are getting positive value. Then again it implies rising water surface profile. Rising water surface profile. It implies rising water surface profile. Clear? Is it clear to all of you? Okay. Now understand next thing. So from this, what we have understood, that first profile M1 will be a rising profile, M2 will be a falling, and M3 will be a again rising profile. Now second thing what we are taking here, if y tends to yn, then what will happen with the dy upon dx value? Formula is s naught 1 minus yn upon y to the power 3 divided by 1 minus yc upon y to the power 3. So if y tends to yn, that means what will happen, my dear? Y tends to yn. So this is 1 by 1. So it will be nothing but 0. So dy upon dx, you are getting something equal to 0. Something equal to 0. So that means if y tends to yn, your slope will be almost tends to 0. That means what? Water surface tries to meet NDA line asymptotically. It means what? Here writing, even I have written, I can write with a different color. It implies water surface line tries to meet NDL asymptotically. Okay. Look at the second part. If y tends to yc, that means this water surface line is trying to meet the CDL line. So in that case, what will happen? Dy upon dx. Now look at, my dear, if y tends to yc, this means 1 minus 1, this lower part will be 0. That means dy upon dx will be tends to infinity. That means it implies water surface line always tries to meet CDL line perpendicularly, because you are getting d tan theta or dy upon dx, or tan theta is infinity. That means theta is equal to what? 90 degree. Clear? Next thing, if y tends to infinity, then dy upon dx will be what? If y tends to infinity, this value you are getting as 0, this value also you are getting as 0. So 1 by 1, it will be 1 only. So dy upon dx tends to s naught. It implies that water surface line always tries to become parallel to the channel bottom at infinity. At infinity. Kindly note down all these points. Kindly copy it fast. Okay. Now with this few things what we got. Now with this few things what we got is that first thing, that all the water surface profile who are trying to meet serial line, it will always meet perpendicularly. First thing, first conclusion what we got. Second thing, all the water surface line which is trying to meet NDL line, it will make asymptote with that NDL line. Second. Third, water surface profile, if they are going towards the infinity, it will make parallel with, it will tries to become parallel with the channel bottom. So these outcome which we got. Other than that, what we got, that M1 profile will be a rising profile, M2 will be a falling, and M3 will be a rising profile. So now based on this, if I am trying to draw water surface profile, look at how it will be. So NDL line, it will make asymptote with the NDL line. As M1 is rising, so it will be a rising profile. As it is going to the infinity, it tries to become parallel with the S0. M2, it will make asymptote with the NDL line. It is a falling profile, and when it meets CDL line, it tries to meet perpendicularly. Why I am giving the dot instead of complete line? Why? Because it tries to meet. It is not actually making perpendicular. It is trying to make. Now third will be, again it will be a rising profile, and it tries to meet perpendicular with the NDL line. Is that clear? So M1, M2, M3. M1, M2, M3. M1, M2, M3. So this we got. This something which we got. Okay. So now here, if you understand, if for M1, as you can see, the depth is more than the critical depth, so it will be a subcritical flow. For M2, again depth is more than the critical flow, again it will be a subcritical flow. For M3, this depth is less than the critical depth, so it will be a supercritical flow. And you know, whenever the supercritical flow will be there, it's an unstable flow, so hydraulic jump will occur. Now see the second case. Now if you understand this part, then second case will be very easy for you. Like steep slope, first one, it tries to make perpendicular with the CDL line. Here the CDL line will be more compared to NDL line, because YC is more than YN. So again you are getting S1, S2, S3. For S1, again you can see the normal depth, the depth is more than the critical depth, so subcritical flow. Here you will find that your depth is less than the critical flow, so it's a supercritical, but YC is greater than Y, but Y is greater than YN, na? So your actual depth is more than the normal depth, but it is less than the critical depth. So it is something like a special case where you are actually getting the hydraulic drop. Now the third case where we are getting YC greater than YN and this part, like you are somewhere here. So if you are somewhere here, your depth is the lower part, na? So CDL, that means YC is greater than YN and YN is greater than this depth. So that is a supercritical condition. You are getting hydraulic jump for that. This is about the steep slope. Now about the critical slope. Here S0 and SC are same. That means your bed slope is equal to critical slope only. Here what you will find, even YN and YC are also same. So if normal depth line and a critical depth line are actually coinciding in this case, here you can see this CDL line and NDL line. CDL line and NDL line. Both are coinciding. So in that case, what will happen? C2 will be missing. C2 will be like C2 does not exist. C1 y greater than yn, yn equal to yc, it is a subcritical condition. C3 y less than yc, yc equal to yn, it is again a supercritical condition. Unstable hydraulic jump is possible in this case. Why we are calling it unstable even though it's a supercritical? Why we are calling it an unstable hydraulic jump? Because you know that critical slope itself is a hypothetical condition. So critical slope, have you seen critical slope till now? No. So only in a book you have heard that, okay, this is the critical slope, or only you can experience with the theory. Critical slope is basically a very unstable thing, or a very unstable parameter, I will say. So here the hydraulic jump will be also very unstable. So note that critical slope profile are unstable. As a note I have given to you, critical slope profile are unstable. All the critical slope profile are actually unstable in nature. Now see the fourth one, horizontal slope. Here as you can see here, the S0 is 0, your yn is infinity. So if S0 is 0, you can see this is the complete horizontal. As yn is infinity, so NDL line you will not be able to find it. You can see NDL line is not there. So if NDL line is not there, then do you really think H1 will be there? Because first profile we are getting above the NDL line. Na? So there is no chance for that. So in that case, H1 is missing in this case. H1 does not exist. This is very important. You need to always remember in which case which one is not existing. H2 is existing. So here y is greater than yc. Like if you are somewhere here, then your depth is more than the critical depth. Na? So it is a subcritical. For H3, y is less than yc. It's a supercritical. So hydraulic jump is possible. Hydraulic jump is possible. Is it clear? Is it clear? Is it clear? Now the next one is the adverse slope. Now the next one is the adverse slope. So for adverse slope, S0 is negative, yn is infinity. That's you guys have given this part. Yn as infinity. So here S0 is negative, that you can see it here. As yn is infinity, you are not able to find a1, so a1 does not exist again. A2, y is greater than yc, so subcritical. A3, y less than yc, so supercritical. But as you can see, this S0 is negative, so hydraulic jump will occur, but this hydraulic jump will be unstable hydraulic jump. So hydraulic jump will occur, but it will be a unstable hydraulic jump. So all the 5 slope I have given to you. If anybody having any doubt, they can tell me. Okay. So if all the slopes you have noted down, now we can go for the combination of slope. Now understand, for combination of slope, you need to understand few things. Only 2 points are needed for you to remember. If you want to make a particular water surface profile for any slope, first point is that your critical depth will not be dependent upon the slope part. Critical depth is not at all dependent on the slope part. Which slope I am talking about? I am talking about longitudinal slope. This point I have also discussed while discussing the critical flow analysis topic. Second thing, second slope will influence the first slope. That means next, whatever the next slope will be there, that will influence what will be the water surface profile in this slope. So right now, currently, if I'm in mild slope, and after mild slope, if you have steep slope, so after mild slope, is that a steep slope or a horizontal slope that affects our water surface profile in mild slope? Are you getting my point? So these point, if you are understanding, then any combination of slope will be easy for you. Any combination of slope will be easy for you. So I am just showing a rough, I will say a combination of 3 slope I am showing to you. Let us see whether you guys are understanding this part or not. So first we have a mild slope. Then we have a horizontal slope. And then we have a steep slope. Then we have a steep slope. As I told, your NDL line will be always same. It will not be dependent on any type of slope. So it will be depend only on the cross section. So it is the NDL line. 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 Now understand how I'm showing, how I'm drawing the flow profile, that you need to understand very clearly. First of all, understand, when you are in mild slope, right now it is the mild slope, it is the horizontal slope, and it is the steep slope. So now when you are in a mild slope and you know that the next slope is the horizontal slope, your depth will rise or fall? It will rise now, my dear. It will rise now. So when it will rising in a mild slope above NDL line, oh sorry, this is not NDL line, this is CDL line. Na? So above CDL line, any surface profile which is rising, it is nothing but the M1. M2 will not be possible, na? It is a falling profile. M1 is the only rising profile above CDL. Now after horizontal, we have a steep slope. So definitely water surface is going to fall. So it will be like this. It will be like this. So you know that water surface profile, if it is a falling in horizontal, there is only one falling profile we have, that is H2. Now in a steep slope also, this profile will be falling only, and it will try to make asymptote with the NDL line, because in steep, NDL line will be below CDL line. You guys are already knowing this part. So in a steep, again the falling profile is only S2. So what will be the right answer for this? M1, H2, S2. So if it is a combination of mild, steep, and mild, horizontal, and steep, so the correct combination which we can form is M1, H2, and S2. Is it easy or not? Tell me. Only 2 things which I have told you, that point is necessary for you to understand, and some common sense, that if after horizontal a steep slope is there, so water will be falling, it will not be rising. These type of common sense will be required. If it is a mild slope and after that it is a horizontal slope, definitely the water surface profile will be rising, because slope is getting reduced, na? Slope is getting reduced. So definitely the depth of flow will be rising. So these are the basic common sense will be required for you to solve this type of problem. If you have understood this part, then please let me know. Chaliye, so few question I will be giving to you. Like this question. There is a free overfall at the end of a long open channel for a given flow rate. The critical depth is less than the normal depth. Okay. If critical depth is less than the normal depth, that means it's a mild slope. What gradually varied flow profile will occur in the channel for this flow rate? There is a free fall at the end of a long open channel. So, dear, there is a channel. After that, we have a free fall. So, do you really think the water level is going to rise? No, it will be a falling water surface profile. Na? So, in a mild slope, only falling water surface profile is M2. So, option B will be the correct option. So, like this basic question will be there. Like this basic question will be there to all of you. Okay, so give me one more problem. Try this one. Question is telling the flow rate in a wide rectangular open channel is 2 meter cube per second per meter width. The channel bed slope is 0.002. The Manning's roughness coefficient is 0.012. The slope of the channel is classified as. So look at my dear, it's a wide rectangular channel. So first of all, R will be equal to Y. Open channel, Q is given to you so small q is given to you 2 meter cube per second per meter. Channel bed slope is given to you, so that is S not 0.002. The Manning's roughness N is given to you. Slope of the channel is classified as. They are asking about the slope. To find out the slope, what we can do, we can find out YC. As it is a wide rectangular section, YC will be small q square upon g. So 4 divided by g, g we have 9.81 to the power 1 by 3. Tell me the value of YC. To calculate yn, what we can do here, v equal to 1 by n r to the power 2 by 3 s to the power 1 by 2. As you are going to calculate yn, that means normal depth. So your s will be s naught. It will not be sf, it will be s naught. So for v we can write 2 divided by yn equal to 1 by n, we can write 0.012 r. It's a wide rectangular channel, so r will be equal to yn to the power 2 by 3. Slope we have 0.002 to the power 1 by 2. So with this, calculate yn value also as well as yc value also. Both value I want from you guys. So YC I'm getting as 0.74. And what about YN? YN I'm getting around 0.688. Okay. So as you can see here, YC is more than YN. So it will be a steep slope. It will be a steep slope. Okay. Try one more question. Try this one also. चलिए अब इस क्वेश्चन में देखिए आपको जीबीए प्रोफाइल पता करना है. So in that case, what we need to do here, we have B width, we have bed slope S naught, we have Manning's roughness N value, we have uniform flow takes place at a channel, so we have Yn value. At a particular section, gradually varied flow profile is observed and the flow depth is measured as, so Y we have, so Yn both we have, the only thing which we need is the Yc. For that we have formula Q squared upon G to the power 1 by 3. Is it Q is given to you? No. So to find out Q is nothing but V into Y. So V is 1 by N. R, it's a Y rectangular channel, no. So 2 by 3 S to the power 1 by 2 into Y we need to do. So small q will be 1 by N, we have 0.04 into R. So area 1 into depth we have 0.6. So we need to find out Q na. So that we can find out 1 into depth we can take 0.5 divide by 1 plus 2 into 0.5, it will be nothing but 1 only. 2 by 3. Slope, bed slope we have 0.0016 to the power 1 by 2 into depth we have 0.5. So I think I can expect all of you to give me the Q value in meter cube per second per meter. Give me the value. So according to my calculation, I am getting around 0.314 meter cube per second per meter. So now if your small q value, then Yc you can calculate small q, so 0.314 square divide by 9.81 to the power Yc. So what is the value of Yc? So from this part, you all can expect a question in GATE exam. So this is a very important part for all of you. So any questions if you have, you can ask me, or else we'll end this class here. If you have any question, you can ask, or else I will end this class here. So with this, gradually varied flow is also completed from my side. For practice, you can solve like questions from PYQs and all. Many questions are there that you can solve. But next, from tomorrow, I will be teaching you the new topic, that is the hydraulic jump. So again, it's an interesting topic. One class will be needed for that. And day after tomorrow, another topic that will be surge. And with that, your course will be over. Okay. So thank you all of you. We'll meet again tomorrow, 8 p.m. sharply. Till then, take care. Bye-bye. Good night.